So converting any number to decimal is very simple. We already seen converting hexa to decimal is possible and it's very easy. Converting binary to decimal is also possible and very easy. But the question is, can we convert decimal to binary? Conversion from binary to decimal is very simple. Remember this 10110, let's say. So you write something like 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 5. It's very easy to convert any number back to decimal. Any number. No matter what number system is, it's very easy to convert any number back to decimal number system. But the question is, can you convert decimal to binary? And that's what we are going to learn here. Our objective is to convert any number to binary number system. I am taking here 583 as an example. So 583, let's write it in a decimal format. 5 into 10 to the power 2, 8 into 10 to the power 1, 3 into 10 to the power 0. 3 is present at its unit place. If I just look at this, how do I know that 3 is going to be at units place? Well, the base is 10, right, for decimal number system. So if I divide this number by 10, the remainder is going to be 3. That's how I know that 3 is going to be at unit place. And this observation provides us the technique to convert any number, any decimal number to any other number system. Let it be binary number system or any other number system. So let me repeat again. We have 583. If I divide this by 10, I know the remainder is going to be 3. Now this 3 will go to the unit place. Now if I divide this 58 by 10, then I know 8 is going to be the remainder. So 8 will go to the tens place. Now if I divide this 5 by 10, 5 is going to be the remainder and 5 will go to the 100 place. So by looking at the 583 and the base that I want to convert in, I managed to figure out every single number at all the locations. I managed to figure out what number is going to be at unit place. I managed to figure out what number is going to be at tens place. I managed to figure out what number is going to be at 100 place. What was my approach? I divide the number by a base value. Here base value is going to be 10. Whatever the remainder is, it's going to go to the very first position or very first place. Then I again divide it by the base value. Here base is just 10. Whatever is the remainder should go to the very next place and likewise. So now let's convert 583 to binary. We have already seen the conversion of 583 to decimal, right? By dividing and taking the remainder, we managed to place every single number at its appropriate position, appropriate place, unit place, tens place and 100 place. We have already seen this entire example before. Now we are going to use exact same technique, just the base value is going to change. Okay, so you divide 583 with 2. The remainder you are going to get is 1. So you place 1 at the very first position. Again you divide 291 with 2. The remainder you get is again 1. You place 1 at the second position. Then you place this 1 at the third position. Great. You divide this 72 by 2. You have 36 with no remainder. So you place 0 here. Similarly you follow the step till you have 0 value here. Now this number is going to be a binary representation of 583. And it's very easy to understand why we are dividing by the base. We took the mod on the whole number with base value. That's why the whatever value you get is going to go to the unit place. But after that, we divide this number by 10. What we have then? 5 into 10 to the power 1 plus 8 into 10 to the power 0. Now you take mod on this. You have 8. But 8 cannot go to the unit place. Why? Because we have already divided this particular number by 10 and converted it to this. So you need to multiply 8 by 10. So multiplying 8 by 10 will give you the 80 value, and this 80 should be going to the tens place because you are multiplying it by 10, right? Why did we multiply it by 10? Because we took mod on this particular number, and how did we got this number? We divided original number by 10. I hope that this converting binary is clear to you. Now you can convert any number that is present with you in decimal format to any other number system. Let's say you want to convert 583 to hexadecimal number system. What you will do? You will take the remainder with 16, right? Base is going to be 16. You follow the exact same process. Instead of 2, it's going to be 16. Simple as that. Let's say you get remainder as 13. So you don't write 13 at second place. You convert this 13 and 13 is represented by D, so you write D there for hexadecimal number system, right? Now we know converting any number from any other number system back to decimal, that we know. And we also know converting any number from decimal number system to any other number system. So any number system can be converted to decimal and all the decimal values can be converted to any number system